Hello everybody, in this video I'll be demonstrating the setup of Dynamic Multipoint VPN Phase 1. Now with Dynamic Multipoint VPN Phase 1, from the hub router we will have a single tunnel that has endpoints on spoke 1, spoke 2 and spoke 3. Usually, if we are not using Dynamic Multipoint VPN, we would have 3 separate tunnels. For example, tunnel 1 going from the hub to spoke 1. We'd have a second tunnel, tunnel 2 going from the hub to spoke 2, and a third tunnel, tunnel 3 running from the hub to spoke 3. In this case, using GRE Multipoint on the hub, we can have a single tunnel that ends at 3 different locations: spoke 1, spoke 2, spoke 3. Now it is also possible with Dynamic Multipoint VPN Phase 2 and 3 that when, for example, spoke 3 needs to communicate with spoke 1, it can in the beginning get the address of spoke 1 from the next hop resolution protocol server, which in this case would be the hub. It would ask the hub, what is the address for the tunnel endpoint, and then spoke 3 would communicate with spoke 1 directly. This is called forming a tunnel dynamically between spoke 3 and spoke 1. Now with the Phase 1 Dynamic Multipoint VPN, which I'm going to show you now, if spoke 3 wants to communicate with spoke 1, all communication between spokes runs via the hub. So I'll be showing you now how to set this up. So just want to orientate you with the IP address setup. So starting with the hub, do a show IP interface brief. On the hub I have a loopback address of 4.4.4.4, and I have this address serving the purpose of a public IP on a WAN interface 200.100.50.1. Now it is important that this 200.100.50.1 address is reachable from the spoke routers, so I'll be testing that first. So starting with spoke 1, do a show IP interface brief, and then on spoke 1 you can do a ping to 200.100.50.1. that is the IP address of the hub, and we're going to source that from gigabit 0/0, which is the public IP on this spoke. We see that ping is successful, and I'll show you the same on spoke 2. Show IP interface brief, do ping to 200.100.50.1, source that from 200.100.50.9. that's working, and spoke 3, show IP interface brief, we can do a ping to 200.100.50.1, and we're going to source that from gigabit 0/0, which is at 200.100.50.13, and that works as well. So as long as your spokes can talk with your hub, as in the ping is successful, then you can go to the next step, which is to set up the tunnels. So I'm starting with the hub. I'm going to make this tunnel 1, so interface tunnel. You could actually start with tunnel 0 as your lowest number tunnel that you can make, but I'm not much of a mathematician. I don't count from 0, so interface tunnel 1, give it an IP address. I'm going to use 10.0.0.254. this is a /24 subnet mask, 255.255.255.0. so my spokes will be 10.0.0.1, 10.0.0.2 and 10.0.0.3. Okay, so this is my IP address for my tunnel 1 interface. For the source of this tunnel, we're going to be using this IP address. So that's tunnel source gigabit 0/0. The hub does not get a tunnel destination because when each spoke connects for the first time, it will tell the hub what its tunnel endpoint address is, for example 10.0.0.1, and it will also tell the hub what its non-broadcast multi-access address is, which is its public IP. For example, in that case it will be 200.100.50.5 in the case of spoke 1. So there's no destination IP address for the tunnel on the hub. So now we need to set the tunnel mode, and it's GRE multipoint, and that's because we have a multipoint tunnel. This tunnel has ends points on the spokes, like it's got 3 endpoints, spoke 1, spoke 2, spoke 3. It's not just a point-to-point tunnel, so that's why we need this tunnel mode GRE multipoint. And then we need IP NHRP network ID 1. Now when the dynamic multipoint VPN gets set up in the beginning, for example when a spoke connects to the hub, and the spoke is basically the NHRP client and it's connecting to the hub as next hop resolution protocol server, the spoke and the hub are going to check a few things to decide if they're compatible, and one of these is the NHRP network ID. So this value must match on the hub and all the spokes. Doesn't matter what it is, but it must be the same on all of them, and it has to be present. It's not optional. If you leave it out, dynamic multipoint VPN doesn't work. The second thing we need here is IP NHRP map multicast dynamic, and what this setting does is your hello messages for whether it's EIGRP or OSPF are multicast messages, but we need a copy to go to spoke 1. We need another copy of that hello message to go to spoke 2. We need another copy of that multicast hello message to go to spoke 3. So what this map multicast dynamic does is all the addresses of the spokes, which are going to be recorded here in the dynamic multipoint VPN service database, are going to be added to the multicast list. So when a multicast hello gets sent out, a copy will be sent via unicast separately to each tunnel endpoint. So the hello will be split 3 times, once for each spoke. So that's the importance of this IP NHRP map multicast dynamic. Bit of a tricky command to understand, to be honest. Anyway, I'm just going to save the configuration, and I believe we've done everything there. Let's just have a quick look. So you can do a show run interface tunnel 1, IP address of the tunnel, IP NHRP map multicast dynamic. This I said needs to be the same on all of them. IP NHRP network ID 1. We've got the tunnel source, there's no destination, and then we've got the tunnel mode is GRE multipoint, because this tunnel has endpoints on spoke 1, 2 and 3. Now let's go to spoke 1. On spoke 1, we go into set up interface tunnel 1, and IP address we're going to make it 10.0.0.1/24, and the tunnel source we're using there it is, what we're using for the tunnel source, gigabit 00, and then the tunnel destination. In this case our spokes do have a destination, which is 200.100.50. It's the lowest IPs that I was using, so it's 50.1. The tunnel mode is the default mode, but I'm just typing it out here so you can see it's tunnel mode GRE IP. And now you need that IP NHRP network ID 1, which is the same on all of them. And then the spoke needs to know which is the next hop server. For example, if spoke 1 wants to get to spoke 3, it doesn't know which public address is going to get it to spoke 3, so it needs to speak to the hub, and the hub will tell it, okay, this is the IP address, 200.100.50. whatever, to get to the other end of the tunnel on spoke 3. So spoke 1 needs to know who's the next hop server, so we say IP NHRP NHS, next hop server, and that's 10.0.0.254. So that's your next hop server, which is the other end of the tunnel, which happens to be on the hub. But as you notice, this is a private IP, and Spoke 1 does not know how to reach 10.0.0.254, so we have to inform it how that is done. So that is IP NHRP map, and we're saying if you want to get to 10.0.0.254, then the public IP that actually gets you there is 200.100.50.1. Now we can see if we can ping this hub router on the other side of tunnel 1, and as you see, that works perfectly. So just to show you, let's show you the tunnel config. Show run interface tunnel 1. We've given this tunnel IP address of 10.0.0.1. We've done this mapping that gets you to the hub. It says IP NHRP map. The other end of the tunnel is 10.0.0.254. The public address that gets you there is 200.100.50.1. This address is referred to as the non-broadcast multi-access NBMA address. That's what it's referred to in the config. I'll show you just now. IP NHRP network ID needs to match everywhere, and then the next hop server is specified this way, which is your next hop server, which knows how to get to all the next hops, is your hub, or what is also referred to as your NHRP server. And tunnel source is gigabit 00. That's interface that's got this public address on it, or what represents a public address. And then your tunnel destination is the public address on the hub. We can do a show DMVPN for dynamic multipoint VPN, and you can see our static mapping that we set up, which says to get to the tunnel address 10.0.0.254 we need to go to 200.100.50.1. Now if we look at the hub, we'll see that the spoke has registered itself dynamically on the hub. So here we can go show DMVPN, and we see the spoke's address 10.0.0.1, and well, that's its tunnel address, and to get there you go to 200.100.50.5, and here it shows a D for dynamic because this NHRP server dynamically learnt that this is the public address, or there what they call it, the NBMA, non-broadcast multi-access address, to get you to this tunnel endpoint 10.0.0.1. So now I will be configuring Spoke 2. So we go interface tunnel 1, IP address 10.0.0.2, 255.255.255.0, tunnel source, it's gigabit 0/0 again, tunnel destination is 200.100.50.1. Tunnel mode is GRE IP, which is the default. Again, you do not need to type this. Tunnel mode GRE IP. I'm only typing it so that you can see or be reminded that in a phase 1 dynamic multipoint VPN, you have tunnel mode GRE IP on the spokes, whereas on the hub you need tunnel mode GRE multipoint, because the hub is connected to multiple points, whereas the spoke only connects back to a single point, which is the hub. And then here we've got NHRP network ID 1, which must be the same on all the hubs and the spokes. And then IP NHRP, who's the next hop server, in this case it's our hub. We put its private IP for the tunnel, and then we tell it how to get there, which is IP NHRP map. And to get to 10.0.0.254 we need to go to 200.100.50.1, and that should work. So you can go do ping 10.0.0.254. That works fine. And now I'm on Spoke 2, just to show you. If we go show IP interface brief, and I want to ping to Spoke 1, so I can ping 10.0.0.1. As you can see, it works perfectly. Now let's set up spoke 3 quickly. So you can go here, interface tunnel 1, IP address 10.0.0.3, 255.255.255.0, tunnel source gigabit 0/0, tunnel destination 200.100.50.1, IP NHRP next hop server NHS is 10.0.0.254. IP NHRP map. To get to this 10.0.0.254, you need to go to 200.100.50.1. And one other catch, IP NHRP network ID, which I almost forgot, 1. So right, now can we ping from spoke 3 to spoke 1? So you can go here, ping 10.0.0.1. That works perfectly fine. Now you'll see on the spokes, if we say show dynamic multipoint VPN, we only have that single static entry, which is here because of that IP NHRP map 10.0.0.254 to 200.100.50.1. So this is from our NHRP map statement. But if we look on the hub should have dynamically learned all 3 spokes. So we can say show DMVPN on the hub, and as you can see, the hub can reach all 3 ends of this tunnel, which is 10.0.0.1, 10.0.0.2 and 10.0.0.3, which it reaches over these public addresses starting with 200.100.50. Thank you very much for watching this video, and I hope that you now are able to set up a phase 1 dynamic multipoint VPN.